Let's get uh, one thing straight from the beginning. So there is no machine learning without the data, so none. And this is the fuel for everything. So when you are on the interview, you sometimes you could skip the data section, and maybe this is the worst advice you will ever get, and this will get you fail. So if you don't talk about the data, that's kind of the most important thing. And key data topics would be four things: labels, how do you know what you're predicting? Features, what signals you are using, and coding, how do you turn this signal into the math? And four is splitting, how do you evaluate your model honestly? The trade-offs, so you don't have label data, what do you do? It's all about the trade-offs. So human labels are great but slow and expensive, so synthetic data is awesome for some like chess or but terrible for some messy problems. Open source data is a good starting point, but you will never exactly get what you need. LLMs, super powerful, but they cost a lot and they can hallucinate, so you will need to use all of these data. Combination. The power combination, you use all of them. So the magic is that they all fall in different ways. So as a system is designer, you can build a pipeline that combines the techniques to create a robust, high-tech data set. And this will be like professional move. And this is a huge signal. Don't forget the negatives. Anyone can find positive examples, but what about the negatives? And for a recommending system, just because the user don't click on something doesn't mean it's a negative. So maybe they never even saw it. So the true negative is an item that user saw and actively ignored. So this finding would be critical. When you talk about features, start broad. You'll use user profile features and item features. So then you zoom in and give like two or three concrete examples for each. And for the user, you might use recent search history, and for item, it might be like its category. So you don't need a list of 50. So just speak about the relevance. So if you forget machine learning for a second, if I ask you recommend a restaurant to me, what would you ask? You would ask about what I like to eat, or uh, you don't need like ID or some other info. So it's same for the model. A feature is only good as that is actually predicted. So your job is to figure out what matters. Feature encoding is crucial. So models are math and they don't see images or speak English, so you have to translate everything into numbers. And going to encode your how to encode your categorical features, so text, images. You need to know the options and why do you pick one over other, and know your trade-offs. So you need to have these trade-offs down cool. So I make to make tables for like for yourselves when you're preparing, and there would be like a lot of dense information about it. So when you train, validate test. So not train test. If you say train test, you will not. You will just using it shorthand, and you fundamentally don't understand how to tune a model without cheating. So validation is non-negotiable. So when you have ton of data and you train validate tests, but what if you only have a few hundred labeled examples? So that's where cross-validation comes in. So that will be more expensive comput computationally. So uh, it would let you squeeze every last drop of the signal from a small data set. Watch out for the data leakage. Be careful how you split. So if you work with the template data, post, social networks, and you can't just do a random split, but you'll end up training on the future. So to predict the past, so you have to split time by time to keep your evaluation honest. That would be the deep dive on data. See you in the next episode.